fun to talk to the past group again, and appreciate the opportunity. I'm just going to jump in here. Today's agenda, we'll talk a little bit about some things that are new from Microsoft. Of course, SQL Server is an absolutely critical component of so many of Microsoft's offerings, and we're going to take a quick look at that from a security perspective. We won't talk. There's so many new features there, but we'll try to keep our security hat on that. Then we'll talk about compliance, standards, and security best practices. Just kind of want to touch on those because I think they're really informative to the DBA community as you start or extend your security projects, and I'll try to bring some of that to the table. Then we'll talk about encryption and key management especially in SQL Server and the VMware environment. And then we'll talk a little bit about our own solution. And that won't be too salesy. I just want to touch on that. Pretty much any key management solution will have very similar capabilities, and we'll just talk a little bit about that. Okay, let's jump in. So one question I often get has to do with always encrypted. This is a new feature in SQL Server 2016, and it's very interesting, creative approach to encryption of data that's in SQL Server. Always encrypted is a client-side application, and what it does is it really encrypts data, but before it leaves your local PC or server and travels over the network and lands in SQL Server. So what this means is that the data gets encrypted at the source and then is protected across the network and as it sits inside of SQL Server. So this is very much, I just want to kind of share this with you, it's very much a 1.0 implementation. A lot of constraints there. When you do a SQL operation, because the data is encrypted on the server, there are some constraints in terms of how that works. But if you're, for example, moving data from in-house into a more exposed environment across perhaps virtual VMware segments, making the data more exposed, it can be a way to protect that data. Or think about moving data from SQL Server into Azure. Those are use cases that Microsoft would use when describing always encrypted. And so that's a new feature. Again, SQL Server 2016 is where that gets implemented. Also, Microsoft keeps extending Azure SQL database. This is the database as a service offering within Azure, and transparent data encryption is now available there. It is in some ways constrained with TDE in Azure. You don't have the ability to bring your own key in the same way that you do with SQL Server in a on-premise VMware or any VMware environment, or in traditional server deployments. So that's a restriction there. I imagine Microsoft will be doing some more development work there as we go forward. Another feature is not related to encryption, but fairly new, is dynamic data masking. So the security implication here is that you can set up rules on users about who can see data and who can only see masked versions of data. So the classic example of where you would use that would be with credit card numbers, for example. So that's a nice feature. Row and column level security. Microsoft's playing a little bit of catch up in this respect. We have new capabilities there for defining security levels at the row and column level. And of course, within Azure, we have the new advanced resource management. I think that's what ARM is, the new version of the marketplace and extensions into Azure. So I know I'm swaying a little, moving a little bit off of VMware, but I think this is helpful for people who are in VMware environments. Almost everybody is thinking about how to get to the cloud also, and so I'm going to throw a little bit of that in as we go. One of the first challenges you have in a security project with SQL Server is really deciding what constitutes sensitive data and that needs to be protected. So if you're doing transparent data encryption and you're encrypting the entire table space, you're going to scoop up all of your sensitive data automatically. But it's really worth taking time to document what sensitive data you're storing and where it's located. In fact, this is a component of many compliance regulations. And so not only are you doing this for your own use and your own understanding, but that documentation will serve you well in a compliance environment. So obviously things like credit card numbers and bank account numbers and social security numbers would fall into the category of data to be protected, but a lot of other information can too. So in a financial sector, non-public information or NPI comes into play. In the medical industry, we have protected health information, PHI, which is fairly well defined. So these kinds of fields should be looked at and protected as a part of your strategy. And documenting where they live within SQL Server is critically important to meeting compliance regulations. And compliance regulations are typically what drive SQL Server users to begin encrypting data, whether in your financial segment or you're taking credit cards in retail, you're in the medical segment and you fall under HIPAA. There's a variety of regulations really come to bear on organizations that need to protect sensitive data. We all fall, for example, here in Washington State, where we fall under the privacy law at the state level. But many of our organizations accept credit card information and process credit card information. So that means we fall under PCI data security standards. If you're a medical entity, if you're a covered entity under federal law, then you fall under the HIPAA and High-Tech Data Act recommendations for protecting data. If you're in the financial segment, Gramm-Leach-Bliley Act comes into play, and the FFIEC is the audit and enforcement organization in the financial industry. That's, by the way, not just banks and credit unions, but it applies to brokerages and trading and many other aspects of the financial industry. And then the federal government itself promotes regulations. So it would be typical for most of us to fall under multiple compliance regulations requiring protection of sensitive data. And this can make the challenge a bit daunting. Fortunately, if we focus on standards for encryption and lining up with industry standards, we're going to line up with a lot of the existing compliance regulations, because it turns out they all have a pretty common source for how regulations get written. And that source is the National Institute of Standards and Technology, which is a U.S. federal government agency that promotes standards around encryption, key management, and so forth. So when the time comes to ask yourself, well, what encryption should I be using? The answer is use a defined standard by NIST. So that would be the Advanced Encryption Standard, for example, AES, or RSA, or ECC, or triple DES. Triple DES is an older standard, still in effect, but I wouldn't start there, even though it's a standard algorithm. Use the more modern technologies like AES. In fact, SQL Server TDE fully supports AES. And when you activate something, if you're going to use transparent data encryption or TDE, definitely would recommend using 256-bit AES. The one thing you do need to be aware of is non-standard encryption. There are some good encrypto algorithms out there for protecting data, but they're not standards. They have sometimes some funny names like Twofish and others. Nothing particularly wrong with those. However, when you're doing a security project, you're doing it to match to one aspect of it is to fully match compliance regulations around that. And most compliance regulations point directly to standardized encryption like AES. So avoid non-standard encryption algorithms. One that I really like actually is homomorphic encryption. It's a relatively new mechanism for encryption. It has the interesting capability of you can encrypt like a number, and then like the number 10, you could encrypt it, and you could add 2 to it, to the encrypted value, and you've got the number 12 encrypted. So it has some really interesting capabilities. But the fact is, it's not a standard algorithm, has not been validated by NIST, is very early days. And you would just want to avoid encryption algorithms that won't keep you lined up with standards. One of the concerns I hear a lot, and it's a very rational concern, is, well, if I implement encryption, what is the impact on performance? Looking back over time, I can understand this concern. Fortunately, I think Microsoft has done a great job for SQL Server users. They'll say, they have said and do say, well, if you implement transparent data encryption in SQL Server, expect a 2 to 4% additional overhead just for the encryption. I find here at Townsend Security, I find that that's closer to 2% in most cases. If you have very large data sets, then we'd really, very large tables, we'd recommend that you do a proof of concept and really measure that, because once you get up into many, many gigabytes of SQL Server table space, you can have impacts on encryption. But for our typical customers, they're going to have a minimal performance impact implementing encryption. So that's good news for us. I think Microsoft has done a good job of optimizing those encryption libraries and making that really straightforward. There are a couple of other areas that you should be aware of, and sometimes people don't think about this, but your backup and restore operations will be impacted because encrypted data is just much harder to compress. And what that means is your backup and restores might take a bit longer. You might see a 25% increase in time and space required to do a backup and restore operation. So there can be an operational impact in that respect. The good news here is that data is encrypted on backup too, and so it's protected from loss in that respect, whether you back up online or you back up on traditional cartridge type media. You're going to be protected there. That data will be encrypted, but it can't be compressed. Compression is kind of a built-in component of almost all save and restore operations, and you're going to lose a little bit of that capability. And the other thing to be aware of is related to high availability. So if you have SQL Server in an enterprise environment, you may be using clustering, you may be running a cold or a hot site, and you have to work your encryption strategy into that picture too. Now, if you're using a key management solution to protect encryption keys away from SQL Server data, that key management solution should solve the problem of high availability by providing a real-time mirroring between key servers. Not all encryption key management solutions do it the same way, so you really need to pay attention there, but that should be a problem that's solved. Okay, why is encryption key management important? Over here at Townsend Security, we say, look, the hardest part of security is encryption, and the hardest part of encryption is key management. So encryption keys are the secret that must be protected. The encryption algorithm itself, AES or whatever is used, is really not a secret at all. It's readily available on the internet from thousands of sources. AES, sometimes called Rindal, is the algorithm that is used, for example, with TDE. So that's no secret. It's the encryption key itself that is the secret that has to be protected. That must be a strong key. It should be stored away from the data itself, and many compliance regulations actually require that. So this is an interesting challenge. With SQL Server, transparent data encryption, and with cell level encryption, Microsoft gives you the ability to store the key locally on the key server. That is a bad security practice. Even Microsoft will tell you best security practice is to store it away from the data. and Microsoft has provided an easy path to plug in key management solutions. We have one, other people do, and that's the best thing to do. And the reason for that is because encryption keys are the secret that you should protect. And it is actually not difficult to retrieve a locally stored TDE key to recover that data. So just a thought there for you in terms of why we focus on key management. Turns out that there are actually business benefits to encryption key management systems. Some organizations have literally thousands and thousands of encryption keys spread across wide swaths of the organization, databases, VPNs, websites, web services, all over the place. So being able to centralize and manage encryption keys actually provides an increase in business efficiency, reduces operational costs, obviously improves security. It's a security best practice, and gives you the ability to demonstrate compliance. So I found this study from Ponemon interesting because we tend to put on our security hats and we talk about why do you do encryption and why do you manage encryption keys. We come at it from security blinders, and it was interesting in this case to find good business case for doing that. Just talk a little bit again about standards for encryption key management systems. NIST is the primary, the National Institute of Standards and Technology is the primary source of standards for key management systems. These are called cryptographic modules in NIST terms, but a key management system is a cryptographic module, and NIST provides both a standard and a certification for cryptographic systems. It's called FIPS 140-2. All professional key management systems will carry FIPS 140-2 compliance and certification statement, and NIST publishes that information online. Really easy to look up. You can just type NIST FIPS 140-2 validation list, and you'll find vendors who have key management systems, all kinds of cryptographic systems, but key management too, in their database. Another standard for key management systems is the Key Management Interoperability Protocol. That's a standard produced in the OASIS standards group. We call it KMIP. It doesn't really apply so much to SQL Server encryption because Microsoft's implementation of key management within SQL Server predates the KMIP standard. But of course, we're all doing projects outside of SQL Server too, and KMIP is an important protocol. So our key manager implements a KMIP interface, the industry standard interface for retrieving keys, querying keys, and doing things like that. And that's an important standard. So really, when you look at key management and you're deploying a solution, you want to look at support for NIST FIPS 140-2 compliance and KMIP compliance. Those are the two key takeaway standards related to encryption key management systems. There are some additional security best practices around key management. You will see these, for example, in the PCI data security standards, things like dual control, separation of duties, and split knowledge. A key management solution, because again, encryption keys are so critical to your encryption strategy. Dual control says that for certain operations on a key management system, 2 or more people should authenticate to manage encryption keys. That's just a typical, dual control is a typical control around any critical systems, think financial systems and so forth. Separation of duties, this comes into play in SQL Server shops actually. You want different people creating encryption keys and managing them as opposed to deploying them within the database. So in most organizations, typically a security team, a security administrator would manage the key manager, create keys, prepare them for use by SQL Server, set up the access controls, doing all that kind of work. Then they would hand information to the DBA that says, okay, the key manager is located at this IP address, here are your credentials, here's the name of the key to use to protect SQL Server. and you would have that separation of duties. The security person would not have access to DBA functions, in other words, access to the protected data. The DBA would not have access to the encryption keys, and then we have proper separation of duties. You will see that concept running through compliance regulations. Split knowledge just says, hey, if your encryption key is ever moved in the clear, it should be broken into parts, and each person should only know a piece of that key. Really, with modern key management systems, that's not so important because they're enforcing secure delivery of keys and not keys in the clear. But these are additional security best practices that you will run into as you begin to deploy encryption with SQL Server. So here's a little schematic on typically how this would work. You have SQL Server itself. If you're using TDE or CLE, cell level encryption, then it's actually SQL Server which is talking to the key server. If you're implementing encryption with embedded key management at the application layer, for example, you're developing in C#, your developers are doing this, then either the SQL Server database itself or the application opens up a secure TLS connection to the key server, retrieves the key, or performs a cryptographic operation. The key server will have its own internal database where it stores encryption keys. A lot of security controls go around that. It produces logs and audits that you can then use to monitor access to encryption keys. So this would be a very typical schematic of what it's going to look like deploying an encryption key management solution. Key management systems are very specialized applications. They would look typical, I think, to a SQL Server DBA in the sense that you've got a database on the key server. It contains data encryption keys. There are attributes related to that, like the name of the key, its expiration date, its current status, lots of typical metadata associated with an encryption key. They, of course, those data encryption keys are not stored in the clear. They're protected with key encryption keys, whose only function is to protect data encryption keys. And this is what basically a key server is doing. It's a database of encryption keys that you manage through the life cycle of the key, and there's a lot of metadata there too. I'm simplifying this because there's a fair amount of complexity within key servers, making sure that data encryption keys are never lost, that you can roll them when you need to, that they cannot be corrupted, or if they are corrupted, that that's detected properly. So I'm simplifying a lot here, but I think you would see this as a fairly straightforward database type of application. Key managers also do something for you that's actually very hard to do in a typical application environment, and that is they generate very strong encryption keys. We call it cryptographically secure pseudo-random number generators. Is typically what is in a key management solution, and that generates strong keys. The strength of your encryption strategy depends directly on the strength of encryption keys. Again, when you deploy a key management solution that has a NIST validation and provably meeting standards, you can be sure that that has been tested to make sure that that is producing strong keys. And that's a critical part of a key management system. I mean, we depend on computers to do things in a routine way, the same way every time, right? And that's the core assumption we make about computing systems. Asking a computer system to do something randomly, like generate an encryption key, is actually a big challenge. But this is something that is baked into the cake with proper key management systems, ensuring that you get strong keys that cannot be brute force attacked to recover your data. So I just touched on this a little bit. Key management systems manage encryption keys from the time they're created through their life until they're retired. Just won't go into that too much unless there are particular questions around that. Again, the goal of a key management system is to stand behind you in your strategy about encryption key generation and management. That's what they do. I talked a little bit about key attributes. Again, they have a user-friendly name. Keys have versions, typically. When you roll a key, you get a new version of that key. That's a brand new key. But we keep track of them. There's an association between keys. And that metadata then lives within the key manager, and you can typically query that with your administrative console for your key management solution. So just to recap, key management systems handle the life cycle of an encryption key from generation, that is creating a strong key, through pre-activation. In other words, the key is there in the key manager but not in use yet. Activation means we're using it to protect data in SQL Server. The key expires but is still available for decryption tasks. It's post-activation, meaning it's no longer used, but we don't want to get rid of it because, hey, maybe we have backups that need that key for recovery. We can escrow the key, and then, of course, destruction. And in the world of encryption, if you destroy the encryption key, you've effectively destroyed the data that's protected by that key. So that's well recognized within the security community that key destruction is equivalent to data destruction as a task. Think of a backup cartridge or tape that falls off a truck. You want to make sure that that data is never recoverable. You don't want a data breach notification. Destroying the key then would be effectively destroying the data. Okay, we have these keys. They're strong. We protected them. We've got them in this vault. We've erected all the walls around them, and we're protecting them. But guess what? We have to use them. So distributing keys to applications and users that need them is a part of what key managers do. Interestingly, Microsoft's architecture for this with SQL Server is called Extensible Key Management. Microsoft publishes an API, what they call an EKM provider API. Folks like us write to software to talk between SQL Server and our key management solution, and that's done over a secure connection. So encryption keys are retrieved by the database itself when needed. It's over a secure TLS 1.2 session. Data is retrieved. In the case of transparent data encryption, basically that transaction is unlock a key so that SQL Server can use it, and that's a secure connection. So we're not leaking encryption key information over the network. And with TDE, it's a one-time operation when SQL Server starts. With cell-level encryption, there can be multiple connections to the key server for symmetric keys used to protect data at the column level. But this is all built into the cake with SQL Server, very, very nice architecture from Microsoft. Outside of that, key management solutions then also provide a number of access controls. So it would be typical, it's typical of our solution, Alliance Key Manager is typical of any key management solution. You want to authenticate administrators separately from, key management, key administrators separately from server administrators, separately from users of codes. So access controls are done that, and a variety of techniques are used. Typically now, PKI infrastructure, in other words, certificates, whether those are stored in the Windows Certificate Store, which is where we put them so they get the proper controls in Windows, or in a directory, you have access controls based on PKI usually, sometimes combined with passwords. And then you have that is your authentication mechanism typically, but there can be more. There can be IP address controls that are possible. You have group or role-based controls. All of these go in, so it's an additional layer of security around your encryption keys. I'm going to switch gears just a little bit with you. One thing that I think that sometimes comes to the table or comes to mind a little bit later in your project is a question that might come up like this: uh-oh, what happens if my key manager fails? If you're running SQL Server in a VMware environment, you have a lot of redundancy capability there. You might be using Veeam or other solutions to help with redundancy, but you have to think about this business continuity. with your key management systems, because your key management system becomes a part of your critical infrastructure. So backup and recovery, high availability, just backing up encryption keys on schedule, making sure those are secure, all of those things become critical components of a key management strategy. So here at Townsend Security, our solution does real-time mirroring from a primary key server to one or more backup key servers, and that failover is automatic. Now, fortunately, systems have become a lot more resilient these days. When we first introduced our key management solution about 10 years ago, it was hardware-based. You had to be concerned about hardware. Now our solutions run in VMware as native VMware instances, in a variety of virtualized environments, and in the cloud. So some of these issues have become simpler to address, but it's still absolutely a critical component of your encryption key management strategy, and must be worked into your initial project. I think fortunately now there are some really good key management solutions that are mirroring in real time and will, for example, match up well with a clustering strategy with SQL Server or other backup and recovery strategy that you have. Secondly, key servers are very purpose-built systems, typically run as a, well, certainly in a VMware environment, it runs as a virtual machine with a single function of protecting your encryption keys. And that means that there's an operating system and systems management. Our solution, for example, runs with secure Linux as its underlying platform, and serves encryption keys both to SQL Server, Windows applications, Linux applications, even IBM enterprise servers. So that means that it becomes a system that itself has to be managed, and we do that through secure web browser interface. So things like network configuration, log management, all of those kind of issues have to be addressed with this kind of solution. So whether you're running hardware or VMware or cloud, these become systems that need management. Fortunately, I think that's fairly straightforward, pretty easy to deploy, and is not too much of a problem. Like any security implementation, security solution, think firewall or DLP or any other switches, key management solutions should produce logs, audit trails of what's happening, and be able to send that information to a log collection server or a SIEM solution. In other words, you need to continuously monitor, as a security best practice, you need to continuously monitor your security products within your environment. Why is that? Well, attackers go after the security products first to hide themselves. And so they'll try to turn off logs, they'll escalate privileges, they'll try to delete logs. Well, you need to be continuously monitoring all aspects of your environment, including the key server. So in our case, we have audit trails, operating system logs, and this information is can all be easily moved in real time to a monitored solution. Okay, switching gears a little bit. Again, what are the barriers to deploying encryption and key management? In the past, a number of things made encryption projects difficult. The key management products themselves were complicated, required consultants. Maybe vendor sample code was missing or poor quality. We were lacking in a number of client-side applications. Vendors made it hard to do evaluations. Licensing could be a nightmare. So fortunately, I think almost in all cases now, a lot of these issues have really been reduced or eliminated. I'm really kind of proud of the work that we've done in that respect, and I'll get to that a little bit more here in a moment. So one thing to remember is that in any environment, VMware or on-premise hardware or in the cloud, you are ultimately responsible for the security of your data. It's true that in a cloud environment, Amazon or Microsoft Azure will provide a certain level of protection of your data. However, you are still responsible for a data breach. You are still responsible for the application layer of protection, and a data breach will fall on you. So it's really important to kind of pay attention to this particular aspect as you move forward. Even VMware's new vSphere 6.5 encryption, which we are working towards supporting right now, which will encrypt images on disk, VMware instances on storage. That's one layer of encryption that is not going to protect everything that you need to protect. So just remember, VMware is not going to be responsible for a data breach. You have to do best practices deploying key management virtual machines separately from the actual SQL Server database. Be careful that segmentation is done correctly. You have to have business recovery, backup, and restore, and often handle hybrid environments. There is some good news here. We worked closely with VMware and a QSA auditor to certify our solutions in a VMware environment as PCI compliant. You can leverage that information, leverage that certification in your own environment. And along with that comes clear guidance from VMware about how to deploy our key management solution, what steps to take when you deploy a key management solution in their environment. So it's really fantastic. I think VMware has a great program for this. There is a product applicability guide, for example, for a key management solution that discusses these issues about how to deploy this and do it from a security best practices as well as from a compliance point of view. So again, I think VMware just did a great job there. Now I'm going to jump into our solution a little bit. I think I'm going to try to keep this at kind of independent level here. I think things I'm saying generally apply to key management solutions across the platform. There are differences in different key management solutions about where they can go and their features. That's just important to keep in mind. So with our solution, we can deploy as a true hardware security module. This is a physical 1U server, fits into a 19-inch rack, hardened for security, and it can be deployed in that fashion. Of course, VMware customers are trying to get rid of hardware. They're not trying to deploy more hardware, but that may, in some cases, may be helpful. We also deploy as a true virtual machine, no hardware within a VMware environment. And then, of course, if you're running SQL Server, you're thinking about cloud. We run in Amazon and Azure, IBM Cloud, and in fact, in any VMware vCloud compliant hosting provider, our solution runs. So thinking about key management means thinking about the different platforms on which you want to run and a bit about your risk tolerance. So I'm just going to skip this slide, system capabilities. We talked about this a little bit, about secure storage and management of servers. Oh, here's an interesting fact. I think that's important for many applications. Key management systems are designed to create and manage encryption keys. But guess what? They almost all, including ours, implement encryption as a service. That is, you don't necessarily have to retrieve an encryption key and then encrypt in your environment. You can actually send data to a key management solution, ask it to encrypt using a particular key or decrypt, and it'll send you back that data over a secure session. So that's very helpful in environments that are more exposed. Think web applications or kiosks or sometimes mobile applications. Retrieving an encryption key is not necessary to perform encryption. You can perform encryption as a service. A little while ago, I was talking about key management solutions and how easy they are or difficult to deploy. Our Alliance Key Manager implements something called Ready to Use. With that feature, on first boot of the Key Manager, we ask you a few questions. Change your password, of course, is one of the things you have to do. But we ask you, well, do you want to create a set of encryption keys that are unique to you? We'll just do that for you. We'll create some certificates that you use for authentication Is this a primary or a secondary server? If it's a secondary server, would you like to mirror between the secondary and the primary? In other words, a handful of questions on first boot now results in a key management solution, active, ready to go, and ready to use. So back in the day when we started, when it often took some hours or days, or in some cases with some solutions, weeks to get a system ready to use, now it's a matter of answering a few simple questions, and you have a fully functional, fully deployed key management solution ready to protect data in SQL Server and ready to go. So things have changed a lot over the years, and key management solutions have become much easier to deploy. Okay, we're kind of coming to the end here. I'm just going to kind of wrap up and see if we have questions. Our solution, Alliance Key Manager, as I mentioned, is certified to PCI DSS compliance in a VMware environment and with SQL Server. So what we did, because we're a partner with Microsoft and a lot of our customers are deploying our solution, we took our Key Manager and our SQL Server TDE application into a validation process with VMware and Coalfire, who are a QSA auditor, to produce an actual attestation of compliance for PCI for key management and encryption for SQL Server in VMware. So what that means is that as you approach a particular compliance project, maybe it's PCI or maybe it's HIPAA, you've got a statement, I think, that is very helpful about the best way to first deploy SQL Server encryption and deploy it in a fashion that actually matches up with compliance regulations. Okay, just talk a little bit about the different versions of SQL Server. If you have Enterprise Edition or higher of SQL Server, you have access to the Extensible Key Management interface from Microsoft. That means plugging in a key management server as a part of your encryption strategy is really, really easy and straightforward. So we ship TDE and cell-level encryption capabilities out of the box with our key manager. It's a typical Windows install, and you're up and running. If you have standard or web or express editions of SQL Server, you don't have the extensible key management architecture. So typically in that case, you're going to deploy encryption at the application layer. And we provide a full set of SDKs, DLLs, sample applications, sample code to really help you get that done. So an awful lot of our, for example, SaaS vendors who are deploying key management based on standard edition of SQL Server have access to those libraries to do encryption. Those libraries just naturally add right into Visual Studio. It's a very simple programming task. The complexity is in our software library, so we've hidden the complexity of negotiating a TLS session, failover in case the key manager is not active, properly caching keys locally, accessing the certificate store for credentials. All of that is built into the DLL. The task for the developer is extremely simple. So this is just a little example. A few lines of code will get you up and running with our SDK. Okay, that completes my prepared kind of comments today about SQL Server encryption. I hope to have talked enough to give you some ideas about what it means to meet compliance regulations, about security best practices, and then dropping into the real tasks of what it means to deploy encryption in a SQL Server environment, whether that's VMware or you can imagine the task would be very similar in Azure or in on-premise hardware. So Dan, why don't we see if we have some questions from the audience?
Thanks a lot, Patrick. We actually don't have any questions right now. So if anybody does have any questions they'd like to ask Patrick, please feel free to type those into the question pane, and we can get those answered for you.
Okay, Dan, also as a part of the work that we do, you'll see my contact information here. If anybody has questions following the session today, please feel free to reach out and ask questions, and we can provide answers that way too.
That's great. And you mentioned earlier you would be providing the slide deck. Is that correct?
Yes, Luke, we're gonna push that up, right? Yeah, we'll provide that to you, and happy for you to go ahead and publish that if you like.
Okay, excellent. Well, we don't have any questions coming in, so I'm going to wrap it up. So thank you very much, Patrick, and to Luke for joining us today. We really appreciate it. Thank you, everybody else, for joining us. We'll have the session recording uploaded to the website in a day or so, along with the slide deck. And then we hope to see you again next week for Hacking SQL Server for Fun and Profit. So thank you, everybody, and have a great day.
Thanks, Dan.